Given two sets A and B, the Cartesian product is the set of all ordered pairs where x comes from A and y comes from B. If we take a subset of the Cartesian product, we have a relation between the sets A and B. Now, while any subset of the Cartesian product is a relation, we'll focus on a very important type of relation. A function is a subset of the Cartesian product with the restriction that every x in A has an associated y, so that the ordered pair xy is an element of the function. And if xy and xy prime are both elements of the function, the second component has to be the same. Metaphorically, every x in A has a unique soulmate in B. We also use the following terms. A is the domain and B is the codomain. We typically write functions this way: the name of the function, the domain going to the codomain. If an ordered pair is in our function, then y is the image of x, and x is the preimage of y, and we often write f applied to x equals y. So remember, how you speak influences how you think. You might be used to reading this as f of x, but it's better to read it as f applied to x to reinforce this idea that y is the image of x and x is the preimage of y. Now, something else to remember is that the more important something is, the more words we have it. And so the more words we have for something, the more important it is. Well, we also use the following terms interchangeably. We call a function a map or a mapping, and we also call x the input and y the output. Now, the important thing to note is that every x in our domain has an image in our codomain. However, we don't require that every element of our codomain has a preimage. This means we also define the following. Let f be a function with domain A and codomain B. Then the set R, which consists of the images of all elements of x, is called the range of our function. So, for example, let our set be 0, 1, 2, and our second set be something else. Let's find a function that maps A to B, and then determine the range. And also let's find a function that maps the other way and find the range. We just need a subset of the Cartesian product where every element of A appears in exactly one ordered pair whose second element is from B. So we might set up our set that consists of ordered pairs whose first elements are 0, 1, and 2. And then we have to choose something for that second element. So let's choose, how about this thing? For all of them. The range is the set of elements of B that appear as the second component. Now, since a long string of parenthetical expressions can be hard to read, we have other ways of representing our function. For example, we can produce a table of values, and remember, our input is our first component, x, and we have 0, 1, or 2, and our output will be the second component, which is just that. Or we could define it piecewise. So our function, well, if x is 0, it's going to be this symbol. Well, actually, it's that symbol if x is 1 or 2 as well. Or since functions describe relations between sets, and we represent sets using Venn diagrams, we could draw the relation with our set A and B. We'll populate those sets with the elements in them. And here we'll draw a line from the preimage to the image. So 0 gets mapped to this symbol, as does 1 and 2. Now, since drawing these Venn diagrams is tedious and complicated, we could also just show our two sets in list notation. So here's our first set and second set, and draw the mapping arrows from our domain to the codomain. Or we could even express this as a formula we can evaluate, except we don't have any formulas that produce results like these symbols, so maybe this won't work. Now, a useful rule in life is don't be boring. So our function from a to b, the images were all the same. So when we make our function from b to a, let's make all the images different. So every component of b should be the element of exactly one ordered pair. So we'll go ahead and set those ordered pairs up, and then we'll choose something for that second component. And so if we try to choose something different, maybe put a 0 here, a 1 there, a 2 there, and we've run out of components, so let's go ahead and put a 1 in that last place. And so even if we wanted to make all the images different, we can't. And again, we could write this in tabular form, or we can write it in piecewise form. So if our x value is this, we get 0. If our x value is this, we get 1. If our input is this, we get 2. And if our input is this, we also get 1. And again, we can also describe this in set form. We have our two sets, and we'll draw those mapping arrows from our first set into our second set. And again, if it's too difficult to draw these circles, we can just go ahead and represent our sets in list form, and again draw those mapping arrows. And we could write it as a formula, except we don't know how to compute with these symbols.